In this video, we will continue our discussion of the chain rule. We will start by building upon the results we obtained in Part 1. If you have not watched Part 1, please stop and watch it first. In the previous video, we took the derivative of this function by using the chain rule. Now we are going to do the same thing, but we are going to look for a pattern to see if we can shorten the time it takes to find the derivative of functions like this one. For convenience, let's first by rewriting this function. So instead of 1 over the square root of 3x squared plus 1, we're going to take 3x squared plus 1 and raise it all to the negative 1/2 power. So remember from the last video that 3x squared plus 1 is what we called u, the inside function. So that 3x squared plus 1 was the inside function. And if you remember from last class, we know that if we take the derivative of this type of function, we need to first find dy du and then multiply by du dx. So in this case, this was u to the negative 1/2. So dy du is negative 1/2 times the quantity 3x squared plus 1 and quantity raised to the negative 3/2, which feels an awful lot like just the power rule. And then du dx, since u is 3x squared plus 1, the derivative of 3x squared plus 1 is 6x. So if I compare this part to u to the u to the negative 1/2, I would bring down the negative 1/2 power, and I would lower this power by 1. And so negative 1/2 minus 1 is negative 3/2. But the question is, where'd this come from? That's not from the power rule from the previous section. Instead, this is going to be part of the chain rule. It's the derivative of the inside function. So what we did was we took the derivative of 3x squared plus 1 to the negative 1/2, just like we did with the power rule. We brought the power in front, we lowered the power by 1, but since this has an inside function, our last step is to take the derivative of the inside function, the derivative of 3x squared plus 1 being 6x. So there's a chain of events that goes on with the chain rule. We take the derivative as normal, but then we go back and we multiply by the derivative of the inside function. In the last video, we also took the derivative of this function, the 5th power of the quantity 4x plus 15. Here, the inside function is 4x plus 15. So if we thought about what to do with this in taking the derivative, it makes sense that the 5 would come out front, and we would lower that power by 1, so that power should be a 4. But this has an inside function, so we would end up taking the derivative of the inside, which is precisely what happens. 4x plus 15 we ignore for the moment. We bring the power in front, and we lower the power by 1. But then we take the derivative of the inside function, so the derivative of 4x plus 15 is 4. So now let's formally state this rule. This is called the generalized power rule. So the power rule, if you remember, took d dx of x to the n. And in those situations, the x and the x matched. In this situation, what we have is a little bit more complicated. We have a function of x raised to the nth power. And as long as that function is differentiable, we are okay. So I just bring this, I ignore the inside function for a moment. I bring this exponent in front, just like the power rule. I lower the exponent by 1, just like the power rule says to do. But then the last step is, because this has an inside function, a chain of events takes place. I look at the inside function and I must take the derivative of that inside function. So let's take a look at an example. Here we have f of x equals the 2/3 power of the quantity 9x minus 7. So here, our inside function is 9x minus 7. So f prime of x equals. So we'll take the exponent of 2/3, we'll bring it in front. We will lower that exponent of 2/3 by 1. So 2/3 comes in front. We're ignoring this 9x minus 7 for a moment. It's just a function of x. Then I lower the power by 1. But again, this was a composite function. So 9x minus 7, I have to take the derivative of the inside. Since there's an inside function, I follow it up with its derivative. So now we have 2/3 of 9x minus 7 raised to the negative 1/3 power times, and now the derivative of 9x minus 7 is just 9. Now we clean this up. We know that 2/3 times 9 is 6 times 9x minus 7, and that's raised to the negative 1/3 power. So we will rewrite this as 6 over 9x minus 7 to the positive 1/3 power. Now we could write that as 6 over the cube root of that quantity 9x minus 7 if we wanted to. In the next video, we will look at taking and applying product rules and quotient rules along with the chain rule and looking at factoring those results.